Hello everybody, my name is Ethan. Welcome back to the channel where today we are hopping right back into our machine learning course on Codecademy. And in the previous video, we started and finished functional programming. Now it doesn't look like we did a lot, but it ended up being one of the longer videos you'll actually ever see on this channel. But, and I had started out that video by saying that I might get through logging as well in the one video. But here we are in a new video doing logging in Python. So I'm going to just jump right into it. Hopefully you guys are having a great day. But yeah, let's just jump into it with logging in Python. So in the introduction, it says in this article, we'll be introducing the concept of logging for programmers. We'll learn about advantages of using logs instead of print statements, and briefly introduce the logging module to write logs in Python. So it looks like logging is something that is kind of similar to print statements. So I've actually never used logging, so this is going to be completely new to me as well. So I'm pretty excited. The advantages of logs. Imagine you are developing an application and upon running tests, you find some unexpected behavior occurring. You decide to add some print statements through the code to see what could be causing the errors. Before long, your beautiful clean code is littered with print statements. As your code becomes messier and messier, tracking where your print statements exist in your program can become a massive headache. These print statements will also need to be removed before the application enters a final production-ready state, which can be tedious. There is a potential risk of a print statement getting left behind. To circumvent a myriad of untidy print statements scattered throughout the code, you can use logging utility to provide programmers with logs that detail either error messages or general information about the output of a program. We can keep our code neatly organized by utilizing a logging utility, making it easier for other programmers to view and understand what is happening and maintain the code. Organized code can also make the task of debugging significantly easier. Using a logging utility can help with debugging by providing detailed information on what caused an error, what time the error was caused, where inside the code the error was caused, or simply providing general information like the value of variables that can be used and we would need to debug. Finally, by using a logging module, we can save time from needing to remove print statements manually. So using logs in Python. Now that we've covered some high-level examples of why we would want to use logging utility, let's look how to log specifically with Python. By importing Python's logging module, we can identify the date and time of custom or error, date and time of a custom or error message. Format logs to make debugging easier. Set severity levels for the logs and output the logs to various streams. We'll briefly introduce these functionalities in this article. In the next lesson, we'll go more in depth on these concepts and practice them with some interactive coding exercises. To show how logging is used in a real-world example, imagine we're building an application that accepts user and password input from the user and is responsible for verifying that the entered information matches a registered user in the system. If it does not, it will raise an error. We can add the logging statements to the function where this code occurs to the log to log the values entered and log the error message if an exception or error is raised. So we first import logging, and then we create a logging object called logger, and we say that logger is equal to logging.getLogger name. And then we define a function called attempt login with a username and a password. We'll say logger.info is attempting to validate the entered credentials. If not verified credentials, logger.error invalid credentials for username. Username.format username is equal to username. Dated timestamps. It is almost always helpful to know the date and time when a logged message or error occurred for debugging or investigative purposes. The Python logging module provides a formatting option to include the dated timestamps for logged messages. Take our login example. Timestamped log messages can help us determine the exact time and date that the login attempts occurred in our application. We can look at an example such as the log message below. Login attempt, invalid credentials for username foo, right? So it tells us that this specific login attempt looked like it was on November 8th of 2021. So, additional formatting options. Debugging an application can be cumbersome, especially the more complex the application is and the more lines of code and modules it has. The logging module fortunately provides several options for formatting what information is included in the log message and how that information appears. We've just seen that there is a formatting option that allows us to include timestamps. We can also include information like the module name, where the module message occurred, or even more, the specific line number within the code file. These formatting options eliminate any need to figure out which module, function, or line number a debugging message originated from. Severity level. There are a varying level of severity for logging messages in Python. Not set, debug, info, warning, error, and critical. These log levels are used in specific cases that range from providing general information to alerting of severe errors. Being able to set a different severity level for log messages allows us to filter out logs of certain levels or limit easily. For a login application, once we are ready to move it into production ready state, we will not need to have any debug log messages included in our log file. The great advantage of using the logging module is that we do not have to go back and manually remove our logging debug statements from the code like we would for our print statements. We can filter out any logging statements that have debug severity level by setting a log level for the logger. All right, log files. Another advantage of using logging module over console print statements is that logs can be saved to a file, allowing the log message to be accessed beyond code execution time. Additionally, the saved logged file can be indexed and made searchable through other software and applications. Conclusion: in short, logging provides many benefits over using print statements, including the ability to set destination for the logged message, formatting options, and much more. All right, let's hopefully get into some actual typing and stuff like that. That's what I'd like to see, and we do get into some actual stuff. All right, introduction to logging. Python uses a logging module within its standard library that allows for each event. We could print statements to the console, but this can quickly clutter our code. The more complex the application, the more difficult it can be to know where to put a print statement and where it has originated, right? The logging module provides several formatting options that make log messages very easy to read. While the print statement can be formatted, it is not as simple and fast as compared to using the logging module. Cleanly formatted log messages can help troubleshoot issues in the application and help future developers with debugging who may work on the application. So, imagine you frequently travel out of the country and develop an application to convert currencies between countries. View the file with printouts.py and compare it to the file with logging.py. Examine the differences in readability and clean lines of code, simplicity, and reduction of repeated code. Now execute with printouts.py by clicking run. So if we compare it with logging, as you can see, everything looks pretty similar. We have a bit of like logging setup here, right? Whereas here, we're just adding print statements every other line. What the heck just happened? Just reloaded it. So yeah, you can see there's print statements in this one with printout. So let's click run and see what happens. So it's giving us a date and time. We did import date time, so it's then saying current rates are this, and then converting info, right? Now execute the with logging code. With this one, it does this, but obviously a lot less code. Imagine you want to view error-related printout logged messages. Consider how this could be accomplished without having to print out several print statements. This can be done easy in the logging module. Wants me to click running in, and we'll introduce it in the next exercise. All right, creating a logger. The first step to utilizing the logging module, obviously, is going to be importing the logging module. We can do this by saying import logging. Next, we can attain our logger object by getting the getLoggerName method. This method takes in an optional single input parameter called name that represents the name of the logger. Calling the getLogger the same name value returns the same logger object. If we get it no name, the root logger is returned. We recommend using the built-in Python variable __name___ for this value, since it will return the current module's name. This reduces the chance of accidentally reusing a logger name and retrieving the wrong logger object. Here we set our logger object to the variable called logger below, and we'll use this later on in the exercise. So next we need to inform the logger where we want our logged messages to go. To do this, we'll use something called a handler. For Python, we will use the logging module's stream handler. This class handles where our log messages will output, and the stream handler class takes in optional single input called stream. If we do not supply this value, the logs will directly go to sys.stder. Since we will want to output to be direct to the console, we should supply sys.stdout as the stream value. Note that we must import the sys or system library to reference stdout as a stream value. So it wants us to do stream handler, logging.streamHandler, system stdout. We need to, and this is strictly to inform the logger where we want our logged messages to go, right? Finally, we can add our stream handler object to the logger. The logging module provides a method called addHandler with the parameter handler that adds a specific handler to the logger object. The handler input represents a handler object to add. Which in our example is the stream handler object, right? So let's import our two modules. So we're going to first import sys, and then we'll import logging. Login. Let's create the logger variable. We're going to say logger is equal to logging dot, I believe it was get logger. Yep, get logger with the same __name__. Perfect. Now we're going to create that handler by doing stream handler is equal to logging dot stream handler, and then we'll do sys.stdout. And then we have to add this stream handler to the logging thing by doing logger.addHandler and adding that stream handler. Much better. Log levels. When programming or debugging, we may want to focus on certain types of events. Lucky for us, they are defined logging events that there are defined logging levels that indicate specific levels of severity for a log message. Each logging level is a constant within the logging module with an associated numeric value. The higher this numeric value, the higher the severity of the logging message. Each logging level is defined as this: non-set, debug, info, warning, error, critical. We should use logging.debug to provide detailed information that is useful for debugging the application. It has a numeric value of 10. We should use logging.info for general operations where expected information or output is logged. It is a numeric value of 20. We should use a logging.warning to alert us to a current or impending unexpected issue or error. This logging level does mean that the software or application will continue to run despite the warning message. It has a numeric value of 30. We should use logging.error to indicate serious problems that cause functionality within the software or application to break. It has a numeric value of 40. We should use logging.critical for the most severe of errors and issues. These errors indicate that the software or application may stop running altogether. It has a numeric value of 50. Finally, the logging.notSet logging level searches for the first not set ancestor logger and inherits its logging level. If there is none, our output threshold will be 0. So it says print the numeric values of each logging level. Remember to import the logging module. So it wants to print all of them. You want to use info for that, just to expected information or output is logged, right? So again, we're going to import logging, and and then we'll create, I'm actually a little confused on what print each value. Because that's not very helpful. I see. That's what it wanted me to do. Okay. I wasn't sure if it wanted me to create another logger and try and store it somewhere. This does make sense though. Finally, perfect. Logging errors and messages. The logging module has several methods that we can use to log messages and errors with assigned severity level. Those modules are debug message, which logs a message with the level debug, info message, which logs a message with the level info, and so on and so forth. Using our logger object, we can call these methods directly when inputting our desired log message as a parameter like the following. The input parameter message is a string variable and can have a custom message or the message contents of a caught error or exception. The logging module also provides a method, log, level, and message, that allows us to log a specific log, level, and message. This level parameter represents the numeric log level to use, and the message parameter is the string value that will be logged, same as above. So we do logger.log, logging.info. This is an info message. All right, inside the division function, add a error message if dividing by 0. So we would want to do logger.info attempting to divide by 0. Inside the terminal, it wants me to write Python 3 script.py 6. Oh. Yep. There we go. Use the log level method to log a critical message in the division function except block. This log should read no dividend or divisional error entered. So we'll add a critical message by doing logger.critical and say no dividend or divisor value in. Few log statements that show the output terminal. Okay. So now if I do sorry about that. Looks good. So now we should be able to check our work, and didn't work, even though it says the exact critical error that Okay. Gosh darn it. Oh my. Script.py. 6. Check work. I did do that. Okay. Holy fuck. It's checking if I entered the exact phrase that they did. That is what's taking us so long. Perfect. Add an if statement is a check if result is equal to none at the bottom of script.py. So I'll add an if statement here. If result result is equal to none. The result value is none. 6. Locate each input statement within the code. After each of these statements, add info log method that stores. Cool. All right, setting the log level. In the previous exercise checkpoint, you may have noticed that when we attempted to add debug messages to our calculator application, they didn't appear in the console. What's going on here? Well, each logger object has a default set of log levels that will output unless a different log level is explicitly set. When we set a log level for a logger, any log message that has this log level and higher will output. The default log level is warning in Python's logging module. We used the default warning level in the previous exercise, so only log messages with warning level or higher were preceded and logged to the console. To change the default log level, we use a method called setLevel, and we'll set the level. this will set the level. Yep, okay. In our calculator application, after the logger object and handlers, set log level to debug. Logger.set level line.debug. Uncomment the last 3 lines in the terminal. Execute Python. Enter 6. Enter 3. Sorry about that. I'll mute my phone now. Uncomment the last 3 lines in the program. Execute, view the log statements, and show that show in the terminal output all log messages, including the debug. Yep. Logging to a file. Up until now, we've used the console for our logged messages. The downside to this is that the log messages are lost once the execution of the application finishes. There's another helpful stream that we can use to direct our logged messages, files. Writing files, logs to a save file makes our logs persistable after program execution, and it allows us to log to be searched through applications like Splunk or ELK Stack. To write logs to a save file, we can use logging module, class, file handler, file name. The file name initializer parameter is a string value that represents the file name for the written log. Similarly to the stream handler, we can add the file handler object to the logger by using the add handler method, as shown below. So we do logging.filehandler, then add the handler file handler. All right, so let's create a file handler. Which should be logger.filehandler using the output.log. And then we can add this handler to the logger object by doing an add handler file check work. If I copy and paste it, nothing changes. Damn it. I mean, it changed that, but output.log. Uncomment the last 3 lines. And we can do python.3 script.py. We'll do 6, 3. And then if we go into our files, we can go to output.log and then starting division 6, 3. Cool. Cool. Logging to console and file. The logging module provides some nifty capabilities to add several handlers to a single one. So we can do this by adding multiple handlers by just adding another handler object. Let's practice. So we're going to create an object called file handler is equal to logger.filehandler using the calculator.log And then we'll add that by saying logger dot add handler file handler. What am I doing wrong here? Am I misspelling something? I'm just going to click get unstuck and then see the solution to see what I'm actually getting wrong. Ah, I'm saying logging. Am I? Is it logging.filehandler? It is logging. That's interesting. Logging.file. Create a stream handler called stream handler. Stream handler is equal to logging.stream handler, and set that equal select post. What is the input for that? sys.std out. Yeah, that's right. sys.std out. And then we can do that again by adding logger.and handler stream. Cool. Uncomment the last 3 lines. I did not, so we have to do python 3.script.py. It wants 6 and then 0, so it outputs to the console, right? But then if we go up here and we go to calculator.log, it also does that here. So now we can check our work. Perfect. Formatting the logs. A crucial benefit of using logging module is the ability to format log messages. This allows us to include helpful information with logged message, including timestamps, the number, the module number or name, the line number, and much more. If no custom formatting is specified, Python uses the default formatting for all log messages. Level name, messages is a string that represents the lane, obviously. Colon separates each of these in a string. Let's examine the formatted. So then it'll go warning, script. This is a warning. Imagine that we want to include a timestamp and a line number in our log. We can create a custom formatter object using the logging module's formatter class, which accepts the formatted string as the first input value. We can do the following to add our timestamp and line numbering formatting. So we can set our formatter object equal to logging.formatter, and then we can actually set what kind of message we want. To set the formatter object to our logger, we use the set formatter format method, where the fmt parameter is the formatted object. Our revised code will resemble this. So it looks like it just stays in one line, and then we also put the stream handler and then put the formatter on that as well. Stream handler. So first, so we create a logger object. Obviously, we create a stream handler, set it to just go to our console. Then we format it using the formatter object and pass that through the stream handler by saying set formatter to set the format, which now produce the following log message. The set formatter method will work on several different types of handler classes, including stream handler and file handler. All right, let's continue on and say in script py, we've preloaded a file handler object called file handler. It's right here. Format the object to match the following. So we can do that by just saying formatter is equal to logging dot, it's probably set format. So formatter. And then we want this specific format right here. So I'll copy that. And then in quotes, I'll paste it. Then we'll do the stream handler dot set formatter. and use the formatter object. And to do this, create a formatter object called, okay, so it wanted it to be called formatter1. I'm sure it would not let me pass unless I set it to formatter1. Then set the formatter of file handler, and I did stream handler. So just do this now so we don't have to sit here. Cool. We have preloaded a stream handler object called stream handler. Format that object, so we can do that again. Again, we're going to create a second formatter now. I assume the format's a little bit different, which it is. We're setting formatter2 equal to logging.formatter, and then put that in quotations, and I'm going to copy and paste this object right here. Oh, what the heck happened? Control C, Control C, Control V. Why is it doing that? Very confused there. And then finally, we're going to add it to file handler, stream handler dot set formatter, and set that equal to the formatter2. And then we can check our work here. Looks like we did a good job. And then uncomment the last 3 lines. Once again, we're going to do this. And we're going to verify that formatted file has differently formatted log messages than the console files. So we'll do that by doing the Python 3 script.py. And as you can see, we can enter the dividend 6, and then we'll say enter the divisor 3. So it looks like in the console it logged it as the time. You guys know exactly what time it is now where I'm recording this video, what date. The info about it, 6, and then again, about 3 seconds later, 4 seconds later, I did that. But now let's go over to the formatted log. That is the file handler, and you can see it's at a different state here. So ends up being a little bit different than this one, and that's because of the way we set it, but perfect, we did it. Using basic config, don't know where I had the dot. Now that we have covered all of the primary features of the logging module, let's cover another method that allows for the configuration of some components in one easy step. The basic config method allows for the basic configuration of the logger object by configuring the log levels, any handlers, log message formatting options, and more in one line of code. Let's say we want to simplify our calculator code by using the basic config method. We can use this method in the following way. Logging.basicconfig, file name is equal to calculator.log, level is equal to logging.debug, format is equal to format. This code automatically adds a file handler object that will write to the file name calculator.log, set the log level to debug, and format all log messages to have a timestamp, log level, and message information. So let's create a logger that writes file code. So we can do that by doing logging. Yep. Okay. So we want to do logger is equal to logging. Instead of this up here, we'll do logger is equal to logging dot basic config, I believe is what we want it to be. It's basic, yeah, basic config, and then we'll first set the file name. File name equals basic oh my, where's my home row? Config dot log level is equal to logger I think I'm doing this wrong actually, because you'd set it equal to log, oh no, never mind, logging We'd actually set it equal to info. And then finally it wants format. Is it formatter? Nope, it's actually just format. It's equal to, oh my gosh. And we throw it in some quotation marks here and we should get the good idea of a formatter. So it wants us to now and check it. Perfect. So now we can get rid of these. And then what? Write it again. Confused why it's not it's not trying to ask us for an input here. Let's see how they did it. Did I mess something up here? I don't know how. I would have. Yep, I did. So, yep. 6, 1. We can now check that the basic config log has this, formatted log has this. Very nice. All right, review. We obviously know all the benefits of logging. We've kind of gone over that. Perfect. Okay, let's do a little bit of a project here. I believe we'll probably have a project and then a quiz. Okay. So you're developing a mobile ATM application that will handle bank transactions such as deposits and withdrawals. The original design of the application, you print statements and print helpful information to the console such as amounts entered for each transaction, transaction status, and date and timestamps. Start off by looking in the code in script.py, try it out for yourself, type Python 3 into the console and click enter, Python 3, script.py, enter, welcome to the ATM deposit. First it's going to ask us for a PIN. Note that if you make any edits to the code, you'll have to click save before running it again. Create a logger object. Okay, so just note that we're going to have to click save right over here. If we put in our PIN, 123 FAR, and enter amount to be deposited, $50,000. Transaction number, date, time, and stamp, and then enter amount to be withdrawn, 0. Balance is now equal to $50,000 or $50,100. Okay. So first thing, we're going to want to import, what's it called? We're going to want to import logging, obviously. I'm also going to just also import sys, just so that we have them. The first step is I'm going to just creating the logger object, setting its parameters. So I'm going to do this, create this little section here, create a logger object that loads, directs logged messages to the console. So we'll do that by doing logger is equal to logging.get logger, and then we'll do sys.stdout. Actually, sorry, when we first create the logger object, we want to just pass in the name. And then we'll do stream handler is equal to logging.stream handler. And we'll do, this is where we'll do stdout. And then we'll do logger.add handler. And then we'll do the stream handler. So we can save this now. You will need to import 2 libraries. That's what we did. So set our log level to info. So first I'm going to do that by just doing logger dot to set the info level, we'll do, it's probably set level logger dot, so it's probably logging, nope, this is logging dot info. Determine which print statement should be replaced by log messages depending on the context of the message. Select the appropriate logging level to use for each statement. Note that this will be the most important and time-consuming part of the project. If you feel stuck, click the hint or look at the solution. So first it's going to say it wants me to replace a lot of the info or a lot of the print statements with info statements. So this one's going to be a logger.info. I guess I should have read the message first. Oh, come on. Logger.info, and I'm just going to re-put that in there. We are going to obviously need to, put input in. Oh my gosh, this is crazy. I guessed the pin. I mean, it wasn't a hard pin to guess, but instead of this, we're going to do a, first again, I'm going to just copy the statement. I'm not going to rewrite all my own statements here. That would just take way too much time. We'll do a logger.error. We'll then keep this input statement again. We'll copy and paste this and do a logger.warning. So yeah, it wants me to then kind of look into this big section here where we put in, save this now, and we are able to, after this, we're going to end up repeating the code by setting a formatter object. So I'm going to do that up top first by creating formatter is equal to formatter object with the, I don't know what, let's kind of take a peek on what a formatter might look like. We'll do this one right here. And then we can pass it in to the stream handler dot set formatter with formatter. So now it has the time actually alongside it. So now we can get rid of we can get rid of our timestamps within these, right? And again, we can get rid of any timestamps now. So, log Okay, save. I'm actually liking where it's at right now. We reduced the repetitive code here, add additional handler to also direct the log messages to a file called formatted.log. So we'll do that too. We'll create a separate stream handler called file handler, and we'll set it equal to file, logging.file handler. That is the formatted.log, and then we'll do logger.add handler, file handler. We've added the direct, and then execute the code. We can execute the code by doing python3.script.py. Oops. Logging dot formatter, right? Obviously, we'll save that now and do python 3 dot, or oh my, I'm looking at the other screen. Holy crap, script.py. Don't know why script is such a hard word for me. All right, hello and welcome to the ATM deposit. Enter our PIN. We'll enter that 1234. Amount to deposited 50 schmackaroonies. We withdrawn 12. We now have a balance of $50,080. Now, if we go into this, we'll go into formatted log. It looks like it ends up putting our information. Let's look at their solution here. They end up logging everything. You just change all print statements to a log, which is pretty interesting. You can just do that. Okay, cool. They did a little bit differently than us. You can do some extra stuff if you want to. But I think that's going to be it, except for the quiz, of course. To configure a logger object for individual modules, which should be used for all individual modules. Nope, it's going to be get logger to retrieve the logger object that can be configured. Okay, we're starting out strong. Print statements are the only method to display messages to the console. Obviously false, we just learned about logs. Which of the following is true of the log level / message level? It will set the logging level for the, nope, it will input argument message with associated with the input argument. If directing log messages to a file, it will log a message with default log. I think this one right here. Yep. What does the logging module do? It is a module that formats all print statements, ingests log files as user input by access log formatted messages that is, yeah. Fill in the code below to direct logs to a file called output.log. File handler is equal to logging.file handler, and then we'll do output.log logger.add handler file handler, right? The basic config method allows one line configuration, right, in the code. So import logging, obviously fill in the code so only logs with severity above info are shown. Logger.setLevel logging.info. Oh, they're backwards. But logging.info. That one should be right. This is backwards. This is obviously backwards. It should be logger.setLevel. But I'm not sure exactly why it wouldn't be info. Complete the code below to format the log of stream handler as the follows. So we'll do formatter logger logging dot formatter, no, it is formatter, and then it's the same as this one. So is this one the same? It doesn't look like it. It looks like this one's the same. And then we'll do stream handler dot set formatter. Cool. Which of the following is not a benefit of using the logging module? Automatically debugs our software. Yeah, it doesn't automatically debug our software. That one's pretty easy. Which is not a logging exception, debug, not set, error, warning, info. So it's going to be exception down here, right? Log messages can be directed to multiple outputs or streams. Log messages can be directed to both console and file. That's true, obviously. And then finally, how can log messages be directed to the console? That's going to be a stream handler. So I ended up getting 2 incorrect. I do want to see this one down here. Above info. Only logs above info. The correct answer is using set level method. Obviously, again, I said I got these ones wrong because they were backwards. That was just a slip up on my end that I put them backwards, didn't spot it. But logging.warning. By setting the logging level to warning, only log messages above warning will be displayed, which includes logs with the severity above info. Okay. I think that is going to do it for today's video. We ended up finishing the software engineering in Python 1 module. So that's pretty good. I'm pretty happy about that. Next, we're going to be learning about the command line, but that's going to do it for today's video. If you did enjoy, please be sure to give it a like, subscribe, and I will see you in the next one. Peace out.